This is video 2 for lesson 11-3, and we are in the middle of the page on page 765. And this time we're going to be looking at the segment of a circle. A segment of a circle is a region bounded by an arc and its chord. So let's look at the picture. A region bounded by an arc of a circle and a chord, the chord that corresponds with the arc. The shaded region in the figure is the segment that we're looking at. The area of that segment can be determined by saying the area of the sector that contains the segment. So that would be the sector that I'm drawing into the first picture. So the area of the sector minus the triangle that is not shaded is going to give us what's left, which is the segment that we're looking for. So again, the area of the segment, that's what we're figuring out how to solve for, is the area of the little piece, equals the area of the whole sector that contains it minus the triangle that is attached to it. Okay, let's do some example problems with that. So we're on example 3, and we're going to be finding the area of the segment. Find the area of segment ACB in this picture to the nearest hundredth. So let's walk through how to do this. This is going to bring up some issues of review. We have the area of segment ABC, and we need to write the word segment, or actually, okay, hold on. What did I do here? I'm starting with the area of the sector. I'm sorry, I didn't write the whole formula there. I'm confusing myself, as you can tell. So I did not rewrite in that spot this whole part. I actually kind of rewrote it down here. But I'm starting with finding my area of the sector, which is the whole sector ABC. As we said, we have to find that first and then subtract the triangle. So the area of the sector is going to be pi r squared, or the area of the whole circle, times the measure of the angle or arc over the whole circle's measure, which is 360. Our radius is 12, so r squared is 144. So it's 144 pi, that's the area of the circle, times 60 3/60ths, because it was a 60-degree angle and a 60-degree arc. Remember, the measure of the arc is the same measure as the central angle. All right, so then we do the math on that. 144 times 60 divided by 360 times pi, so that's 24 pi. So we have the area of our sector now. Now we're going to do the area of our triangle. Here's the triangle. It has a 60-degree angle, and it's an isosceles triangle because it's bound by 2 radii, or its sides are 2 radii. So that means that these two angles also have to be equal because it's an isosceles triangle. And if this is 60 and these two are 120 divided by 2 to get to a total of 180, then this is going to be a triangle with 3 60-degree angles, making it an equiangular and equilateral triangle, with every side having 12 inches as its length. So we know the area of a triangle is 1/2 the base times height, and we do not have a perpendicular height in here. So what we're going to have to do is draw one. I have drawn my triangle with sides 12. I didn't label that, but I labeled the bottom side as 12. And then I drew a perpendicular height, which divided the 60-degree angle up here into 2 30-degree angles. And of course, each angle is 60, so this one is 60, and we now have a 30, 60, 90 triangle. That means, and of course we split the base in half, so it's only 6 on this right triangle on the right side. So if this is 6, if the shorter leg is 6 in a 30, 60, 90 triangle, remember that the longer leg is 6 radical 3. That means we don't have to use our trig functions. We just use the special right triangle things that we've memorized. So if the shorter leg is 6, longer leg is 6 radical 3. Now let's do our base times height divided by 2. So we're going to say the base of the triangle is 12 times the height of the triangle, which is 6 radical 3, divided by 2. And our area for that triangle comes out to be 62.4. Now's where we plug in the formula for the area of a segment. We say area of sector minus area of triangle, and that when we say 24 pi minus 62.4, we get 13.00 inches squared because we were told to round to the nearest hundredth. Okay, hope that helps. Let's see if there's another problem here. If there's not, except for the check it out. Let's look at that one. Find the area of segment RST to the nearest hundred. Let's look at this. RST to the nearest hundred. Remember that we are going to have to say the area of the sector, the piece of the pie, minus the area of the triangle, and that's going to give us the area of the shaded segment. So I started with area of the sector. I'm going to say pi r squared times m over 360. Going back to this, you can tell that it was labeled as a 90-degree angle and therefore a 90-degree arc. So we have, oh, and our radius was 4. So we have the area of the circle being 16 pi times 9.